All right, so here's my simplicial complex on three-dimensional data. Of course, it is random data, so it doesn't look like much. Actually, kind of looks like a big mess here. But you can see there are some, maybe right here, there are some holes and maybe some concavity. It's really hard to tell, but ideally you would vary the threshold distance and then see if those bigger holes and concave structures persist. I will apply this to the COVID-19 data, but I'm not exactly too stoked because I don't know that it's going to tell me anything more than random data will. And honestly, oh, that's pretty cool. Looking, I don't know what that looks like, but it looks pretty cool. Anyway, and it does look a little messy, so I might need some shapes or to really know if this is doing what it's supposed to, or if I've missed something somewhere. Let me back up and kind of show you where I was going in my code, and we have this two-dimensional simplicial complex that I did in the last video. It actually didn't take me too long. See, it's going to go slow a little bit because it doesn't like my video for some reason. It doesn't like me having my video up while I do all this. My computer's pretty old. But anyway, I did that two-dimensional simplicial complex. It looked kind of messy, so I backed the threshold distance off, and I am using the quick algorithm just for this because I don't know. I just wanted to kind of have like a little one-line thing and get it in the ballpark. So that algorithm actually does not preserve duplicate distances if duplicate distances are in the data. Um, I don't think it really matters that much. It is still kind of that lower quartile, that first quartile. Oh, so that's what I was going to say, is actually that one was on 3/4. The third quartile of all of the distances. So basically, I took the dissimilarity matrix, broke it down, took all of the stuff that I didn't need away, then I sorted it, and wherever basically 3/4 of that was, that's where I said that's going to be my threshold distance. And um, but I thought it was a little bit messy, so I decided to do it in the third dimensional version. I decided to back it off to 1/4 or first quartile. And I'm thinking my algorithm might be a little bit off. Maybe it's a little off in my head because it was still like, I don't know. There's something I have to dig deeper, I think. But as you can see here, the third, I think this was awesome. I was on 10 data points, but this turned out really great. I was real happy with this because you could see there's a triangle there, or the one simplex, if you will, at the top and kind of on the bottom right-hand corner, and even in the middle there's looks to be another one simplex, and that's really what I'm looking for, is kind of the triangles. So I decided, you know what, let's up the ante, just a bunch more data points. Why not? Let's just see what it does. Then it came out with this, and I was like, what? Okay, that's a little bit messy there. I don't know, and it may just be because it's random data. There may be something going on that I'm not seeing. I'm gonna have to explore more, and yeah, we'll just see. I might just need something that actually has a shape, better for testing. We do it on a torus or some sort of mathematical shape, and then and see if it does what it's supposed to on those. But otherwise, and so on the, let's see if I can pull that back up. On this guy, oh, I don't want to do that. I'll just do this real quick. And so on this one, I backed it off to a full like 1/16, and it's still, slightly messy. So It does kind of concern me a little bit that I am missing something, but I think that when I get the slider, it will be more apparent if I've done the algorithm right. I can also choose to do the slider just on the entire, as a smooth transition from the entire, from basically normalized 0 to 1, and then each of these lines will pop up, or I can do it kind of broken up into those quartiles, so maybe like 1/16 or 1/32 even, and then 1/16 and so on, and break that up, and then it'll kind of jump. There'll be a lot more lines, but that's kind of what I'm doing here in a sense. Even though I'm taking one snapshot, but with that slider, I'll be able to take multiple snapshots, but it will be the quartiles rather than just a smooth transition from of all the distances. And I think that if I do that smooth transition, it should be okay if somehow I messed up my algorithm, which is perfectly possible. I don't know, it's normal, but anyway, so yeah, that's basically all I have for today. And, thanks for watching. And I hope this was kind of interesting for you. And reach out and let me know what you think. And I will be putting it on the COVID-19 data and maybe moving to something else. I'll be doing that slider. And that'll be pretty much it. Yeah. All right. Thank you. Bye.